Hello everybody, I am Jadushan Rajasagaran and I will talk about our work on tracking people by predicting 3D appearance, location and pose. We are presenting FULP, an approach for tracking people in video by reconstructing them in 3D and predicting their 3D appearance, location and pose. FULP is very robust in diverse settings including in-the-wild videos, pedestrian videos, sports videos with extreme poses and videos with short changes like movies and more. The main idea of FULP is to lift people to 3D and use their 3D representations to build prediction models of their future appearance, location and pose. Then, given these predictions, we can easily associate them with the people detected in the future frame. The first crucial step is to lift people in 3D. We reconstruct each person and represent them using their 3D pose, 3D location and 3D appearance. Given this 3D representation, we aggregate information over time and build models that predict the future states of each human's location, appearance and pose. Let's investigate how each of these work in detail. For location prediction, we make a simple assumption that the human motion in 3D space can be linearized in a local window. Therefore, we use a simple linear regression to predict the future location of every people. For appearance prediction, we assume that the human appearance do not change rapidly over time. As the person moves around the scene, we see different parts of the person. And since our appearance model is represented as a texture map which has correspondence already built in, a simple moving average on this space is sufficient to complete and predict the appearance of the person. For the pose prediction, we start with a sequence of a track and predict a motion feature using the previous works on motion recovery models. Then, for every future frame, we can predict the changes in the human pose. Finally, given the predicted state of each tracklet, we associate them with the detection of a new frame. By learning a simple distance function and solving the assignment problem using Hungarian matching. Now, let's look into more qualitative and quantitative results. We evaluate FULP on various datasets on various metrics. And across all dataset and all metrics, our method achieves state-of-the-art performance. Let's look at some qualitative results. Here, if we focus on this football player pointed in red circle, he goes through an occlusion and we see only a part of this person in a quite unusual pose. However, FULP was able to track this person successfully. As we go further, he is going through multiple occlusions and in all cases this person is tracked successfully. Now we will compare FULP with recent tracking methods. In this scene, if you look at the football player, he is going behind two players of which one of them has similar appearance. Now, if we look at the recent works based on 2D representations, at the bottom left, track former starts with a green bounding box for this person. And the identity changed when that person is viewed partially. And as we go further, the identity changed again due to the similarity in the appearance. Next, if you look at tractor at the bottom right, the person of interest starts with a green track. And similar to the previous error, the identity between two players are changed. Finally, we show tracking results from FULP. Our track starts with a pink identity, and as you can see, even if the person is partially visible, FULP was able to track this person successfully. As we go further, the tracklet identity is kept same. Thanks for listening to our talk. Code and the demo are available at our website, and please visit us at our poster.